Uh, Hello, good evening, everyone. This is Dr. Rajesh Ghosh from Indian Chamber of Commerce, and welcome to the 40th episode of ICC BiZ Live, where we bring C-suite people to disseminate knowledge among our members and our viewers. Today, we have a very high profile person with us, Mr. Abhishek Chauhan, MD of Sonatype India. He is one of the star speakers in our World Technology Conference, which we are organizing in Mumbai on May 8 and May 9. There, you can, right now, you are seeing him over the web. There, you can see him live, hear him live, and raise your questions to him like in live. And, uh, and now I would rather hand over the mic to Mr. Chauhan to give a detailed introduction of himself and what he and his organization is doing.
Thank you so much for
Over
the
to you, sir.
opportunity, Dr. Abhishek Chauhan and Indian Chamber of Commerce. It's a privilege for to be invited to this ICC BiZ Live over here. Talking a little bit about me. So, Abhishek Chauhan, this side, I have over 2 decades of experience working across industries and globally. I have lived and worked in almost all of the tier one metro cities in India and a lot of the capital cities in the world globally. The kind of work I come from is core software engineering. I'm a pure play software engineer at heart, irrespective of the role designation that has been given to me by the company over here. For me, life is simple. Life is you work hard, work what you do, like on, and life becomes easy going forward from there. That's what I truly believe in. Sonatype as an organization has origins in open source. We are the maintainers for Maven Central, which is the largest public repository for all Java web components. So if you are a Java developer out there, you would have downloaded the components, binaries from Maven Central, and we are the maintainers from that. Apart from that, we are a product engineering organization, which are very specific into the DevSecOps world. We basically have products that help people stay secure, the code, the software being developer, help secure it from an open source perspective. That's a little bit about me and my company over here.
Coming to today's topic, before we go into the detailed technical intricacies, we would like you to explain the basic concept of a secure application software. Traditionally, people think all softwares are secure, but still hacking, cybersecurity, and firewalls and all these things are there. So, what is the basic concept, sir?
So when we think of security and software security from that matter of perspective, most of the times people think about cybersecurity. What most people don't realize is cybersecurity is the last piece in the chain over here. Cybersecurity is when the particular piece of software is already deployed into a particular system environment, could be on-prem, could be cloud, doesn't matter, and people are already accessing it. It's available to the users of that particular application. That is when we try to protect that software from cyber threats. But if we think of security from a software standpoint of view, security starts a lot before that. Most of the people who have been developers or engineers in the quality testing DevOps side of the realm would understand that there is one more piece of security before cybersecurity. That is at the time of build and deployment. At that point of time, you basically scan your software for different sort of vulnerabilities. You do security scans, you do a lot of different type of load performance testing, you do a lot of code quality tests over there to make sure that the software that you are building and deploying, it is secure. You run checks on it, different kind of checks. But there is one more piece of software security which a lot of people don't realize, and that is where the shift left concept comes into picture. So in this whole pipeline of software development, build deployment over here, why not shift left the concept of security in software development processes at the time of code development itself? When a developer is writing code, developing a particular piece of functionality, a software over here, at that piece of time itself, a lot of people don't realize that irrespective of the programming language, irrespective of what kind of application they are creating, in which company they are doing it, 60 to 70% of all software is made up of open source. If we talk about it in the world of Java, everything from Spring Boot to Batch Spring over there to Struts are open source libraries that people utilize. Similarly, in the JavaScript world, everything from React.js libraries and NPM ecosystem to Vue.js libraries are open source libraries that people can just utilize and build their software on top of it. People don't realize this, but all of these libraries that they are utilizing can also have a flaw in it, can have vulnerabilities in them. And that is where the concept of shift left, which I was earlier talking about, comes into picture. That the software code that we are writing, why not secure that software code itself? Why not make sure that the open source components that we are utilizing, they are protected against threat, they are secure by nature over here, and that will help us develop a software which is a lot more secure, making sure that at the end product, at the end of the day, which gets deployed, which is accessible to public, is much more secure by nature. That's a little bit about what the concept of software supply chain security comes into picture.
That is the two useful learning points I took away. 60% is open source, and cybersecurity is the last stage in software security. Very useful learning points. I hope the viewers have also noted this. Now I will come to the questions. Now, how is the integration of AI reshaping traditional application security practices? According to my knowledge, it is automating the same. But can we afford to automate the manual checklist process? I request you to explain it as an expert you are.
Sure. So all of us talk about AI these days. Doesn't matter where we are sitting with. It could be a office environment with office colleagues. It could be a personal environment where you are sitting at a family function. AI is a hot cake these days. Everyone talks about AI. Everyone wants to understand what AI is doing, what all are possibilities with AI. All of us have been exposed to the different kind of AIs, from everything from a chat GPT to a lovable to creating videos in Gemini. All of us have tried our hands at that. But when it comes to the world of software engineering and software development, AI has done a lot. Back in the day, one of the biggest time taking process used to be the art of writing code, learning syntaxes, understanding the use of a particular type of data type, understanding how a particular code structure works, what is the better architecture pattern, used to be one of the critical tasks in the software development process lifecycle over. In today's world, AI does a lot of that. AI as a coding agent, all of you would have been familiar with the terminology called vibe coding, which basically is a non-engineer sitting with a AI and working, instructing, prompting the AI to create a piece of software. That works very well for boilerplate code. For very simple to do code, AI can do a lot of good work, believe me. It can do the work that humans will take really long. It can really do that fast and at a good efficiency also. The place where AI lacks from a security standpoint of view is doesn't matter which model you are using. It could be the latest model of Opus, it could be the latest Sonnet model, Gemini model that exist, Anthropic Claude models that exist, doesn't matter. All of the models rely on the information that they have accumulated in their LLM, which is a majority of that information comes from the scraping of the different things that exist on the internet. And that piece of knowledge that they have is always a little outdated. The models don't have real time context. The models are generally trained at least on a 30 or 60 days before knowledge. So if you ask your AI about an event that happened last week, it will not be able to give you the full information. The reason for that is, like I said earlier, the knowledge of the model, the context of the model is a little older than that. It is okay when we think of writing code, but it's not okay when we think from a security standpoint of view. The world of security is evolving very fast. It is changing. We all have heard about OpenAI, Mythos coming out and finding vulnerabilities across softwares. So the world of security is evolving very fast. And one of the problems that it has created is people are using AI to write a lot more code as they move ahead. And when they use AI to write a lot more code, AI doesn't know what all latest vulnerabilities, what all latest threats exist in that piece of software that it is using for writing that code because it doesn't have the latest context over there. And that creates a problem from a software supply chain perspective. That if your source is not secure, the end product can never be secure over here. So from an AI standpoint of view, using AI smartly to know what code it to write, how to write, but at the same point of time, having a human in the loop is very important. Like I tell people, doesn't matter what AI does, the core concepts of engineering, which are basically security, scalability, performance, these core concepts are not going away. And these core concepts are where the human, the engineer comes into picture. They are the one who don't have to do the dumb work anymore, like making a simple UI change, writing some boilerplate integration code, adding some CRUD operations, creating UI screens based on some Figma mockup. Engineers don't have to spend their time in writing all of these boilerplate codes. Engineers should actually now be spending their time in solving either technical challenges or business use cases. Their knowledge about the domain that for which they are creating the product knowledge about the domain, or their technical expertise from a security and performance perspective are going to be the key differentiating factors for them as they move ahead. In terms of checks, people need to remember that AI is AI. AI always hallucinates. All of us have once a while asked a question and received a reply which did not make head or tails out of it. It was completely backed out. And the reason for that is simple. AI is good. AI can do a lot of things. AI will help us process our stuff a lot better, a lot faster, at a high enough efficiency. But closing your eyes and blindly believing it is the recipe for disaster. We need to be smart as engineers. We need to really be cautious as executives in terms of what we are asking AI to do and where we are using the human intelligence that comes into picture.
Nicely explained, sir. This absolutely resonates with what I heard from one of the IT expert. AI will not take your job, but someone using AI will. Now I come to the next question. What do you mean? What does secure by design mean in in the software development life cycle? Whether it is manual or AI driven, whatever. What do you mean by secure by design?
So a little earlier, we were talking about the process of shift left from a security standpoint of view. That is where the secure by design principle comes into picture. When we talk of a software, like I said earlier, it's not just the end product from a cyber security, cyber threat perspective. It's about at the time of building the components that it uses, the whole dependency tree that exists over there. It's also about the code that you are writing. If the code that you are writing is secure, it follows the best practices. At the same point of time, the open source components you're utilizing are secure. That will be that is so much better. Think of it like think of it from a development standpoint of view. Imagine you are writing code. Doesn't matter what IDE you use, from Visual Studio Code to IntelliJ to anything out there, Eclipse. You are writing your code and you import a namespace, you import a file, and as soon as you write that code, your IDE is able to tell you, hey, this particular component has a vulnerability in it, has a flaw in it. Wouldn't your life will become so much more easy? You will be so much more happy because you will know about the flaw at the time of development of your code itself. You don't have to worry about you writing the code, building it, pushing it, and then a security scan running and finding some flaws in it. By default, your software would be so much more secure over here. So as we shift left the security concept over here, the secure by design concept comes into picture. That by default, the software is a lot more secure.
Will secure by design be able to check Mythos attack? Now it is the hot topic of discussion.
So secure by design, I'm going to generalize a little bit and not just talk about mythos over here. So when we talk about secure by design, that is supposed to protect you against most of the vulnerabilities that are known that exist out there. There will always be the edge case where something that is not known about comes into picture. I'm not sure how many of you are aware, but around a few months back, I think in December, January timeframe, there was a React JS vulnerability. React JS is one of the most popular JavaScript libraries that exist out there. Uh, Most of the companies out there use some variation of React JS in one or the other projects for them. And there was a CVE score 10 vulnerability that came out in React JS. Score 10 basically means the highest level of threat over. And any company that was using that particular version of the React library had to basically pivot and upgrade the version to make sure that their software is not impacted, their systems are secure. When we talk about secure by design over here, by default, when we are creating the software, we try to eliminate the known vulnerabilities. We try to make sure we don't use a component, we don't use a binary that has a malware in it, that has a vulnerability in it, a defect in it. But when it comes to the world of vulnerabilities, it's ever evolving, and there are going to be always scenarios which are not known. And then once they get known, people will have to pivot and quickly handle them.
How does automation change the balance between speed and security? in DevSec ops or say secure application software. Speed. How do you balance that? I mean, the trade-off between speed and security. How do you balance?
AI is going to dramatically change the speed at which things are going to happen. A lot of good automation will come into picture, automation which will take care of a lot of the manual work that right now is being done, a lot of the boilerplate work that people are spending their time and human hours on. But at the same point of time, like I mentioned earlier on, we need to be very conscious about the end product and about the usage of AI and automation through it. Humans will always have a superiority over AI because humans are intelligent by nature. AI is intelligent only based on the context it has. So we need to understand this difference. We need to understand the levers that exist out there and how to utilize them. By automation, we should be using AI as a tool and a technology to automate things. At the same point of time, we should be conscious of not letting it go wild. AI is a tool and technology, and like any tool and technology, it is only as good as it is used. The control, the guardrails are very important. The better guardrails that exist, the better output we will get. Automation is needed, automation is helpful, it will help speed up things so much more. And every company out there is right now experimenting with AI based automation into different aspects. But at the same point of time, we should not forget that security is a key critical pillar for us. Anything that is not secure is, I honestly would say, is not worth it. Security is non-negotiable. We cannot keep security on the sidelines and move ahead with just speed. Both of them have to walk hand in hand, and that is where equilibrium comes into picture. Every company, every individual out there will have to find this equilibrium of how to balance speed with security.
And for me, is the what you said about shifting left, moving security to the earliest stages of development. Very useful learning point for me. My next question is about vulnerability detection and threat modeling. How do you do it? What do you use? What do you apply?
That's an interesting question because it does a little bit of deep dive into our products and the specification of how Sonatype as a company is the leader in the software composition analysis over here. So when we talk about vulnerability detection, threat analysis, it's a lot more vast and data intensive field than people truly realize. Taking a step back and talking a little bit about what vulnerabilities are. Vulnerabilities are basically flaws in the code that can be exploited. The flaw could be intentional or it could be unintentional, doesn't matter. If there is any flaw in the code base that can be exploited for any sort of unethical gains, that is basically what a vulnerability is over here. The way it works is every most of the softwares out there, like I said earlier, are made up of 60 to 70% of open source components. What most of the engineers don't realize is that even these open source components are made up of other open source components. There is a whole dependency chain that exists, which comes together to create a piece of software. A lot of the popular libraries that people use in day to day, they are not one level, two level, or three levels deep. Most of those libraries are 7 to 11 level deep. Like if you were to go and find the original piece of code which has been written, which doesn't consume any other library that exists out there, that would be most probably 7 to 9 levels below over there. So when it comes to the art of vulnerability threat detection over here, it is based a lot on data science. The learnings, the data, the understanding of the dependency chain, the understanding of the open source components that Sonatype as an organization has developed over the past 18 years is the basis of how we are able to do the vulnerability analysis so well. We have very specialized data science models which can be which are utilized, which run on a real-time basis, near real-time basis on the data being fed, and they are able to find vulnerabilities in those components based on historical markers to other known vulnerabilities that exist from a security research perspective. We have a specialized security research department team whose only job is to find flaws, find vulnerabilities into softwares, being able to understand how to decompose a binary, and after decomposing a binary, finding if it has any vulnerability or not.
Now, my next question is what are the key differences between traditional AppSec and AI powered AppSec?
That's an interesting question because the world of application security is evolving very fast. I'm trying to form the right words to answer this question in all fairness. The way I'm thinking about this is the world of AI powered AppSec is still evolving. Like I would say we have just started on the journey of AI powered AppSec over here. It's still a lot of evolution is pending. In the traditional AppSec, the security teams were always at par or almost at par at the pace of development, at the pace at which software evolution was happening. Assume a scale, x and y axis over here. So if this was assume a 45-degree angle, was the speed of software evolution, security always used to be within 5 to 10% of that software evolution. It was able to keep pace with the evolution of software. And that is how the traditional AppSec used to work. In the AI powered world, like all of us know, the, the software evolution process has gone wild. It's no longer 45 degrees, it's 160 degrees over here. The software evolution has become so fast, so ever evolving that from a security standpoint of view, it has become a challenge keeping pace with it. And that is where AI powered AppSec comes into picture. We have to be able to utilize the capabilities of AI to make sure that we are able to keep pace with the software evolution and we are able to better protect ourselves. I was mentioning earlier a scenario where a developer is able to find vulnerabilities in the code that he's writing within the IDE itself. He doesn't have to worry about it going through a security scan in the build and deployment process. So we have developed a product. Sonatype has a product called Guide, GUIDE. That product is something that you can integrate into your IDEs. It could be any IDE you want, anything from Cursor to IntelliJ to Visual Studio Code to anything else that you want. We have MCPs and APIs available, integrations available. And while when you integrate that, it will be able to tell you that information about the code that you are writing in real time. At the same point of time, a lot of the code these days is actually not written by humans. A lot of the code these days is written by AI. That's the honest answer. What our product can do is our product can work in tandem with your AI coding assistant. Whatever model, whatever framework, tool you use, doesn't matter. It will work in tandem and it will tell the AI coding assistant which package that it is using, whether it is secure to use or not, whether it has a known vulnerability or not. If it has a vulnerability, what is the risk score of that vulnerability and other details. So that way, not just the code that you are writing, but the code that your AI assistant is also writing will be secure, will be much more secure by design.
My next question is on audit. I have heard of cyber audits, but do you audit if audit the software also than the AI models used in software development?
That's a great topic. It talks about the governance of AI. AI governance comes into picture. So as humans, we all are have a natural bias. That's a general human trait, a human personality. We all have a natural bias towards one thing or the other. And unfortunately, since AI is being trained on a lot of the data that is being created by humans, there is a certain aspect of bias that comes into AI. Like I said earlier, the biggest differentiating factor is humans are intelligent by nature. AI is intelligent only based on the context it has. And if the context that it has a flaw, has a bias, that bias would be visible in the output that AI gives. Talking about the governance side of AI, yes, that is one thing we all need to be very cautious about. We all need to understand because it is a pit stop. It's one of those things we have to think not at the end of the workflow, but from the starting of the workflow itself. That AI will hallucinate once a while. AI will have a certain type of bias based on what context it has been given. At the same point of time, our ability to set up guardrails, to set up checks along the way of AI being used is going to be the key differentiating factor in terms of how successfully it works versus how much governance it has. There are a lot of good tools and techniques that are available out in the market from an AI model governance perspective. One of the things which I feel This is a personal opinion completely, which I feel will happen in the near future. Is right now we have these large language models like the chat GPTs and the Geminis of the world, whose context is very wide. Like they practically know most of the things that exist out there on the internet. You can ask them anything and they will be able to give you some answer regarding it. I feel in the future, instead of these large language models which are much smaller but much more specific context based would become a lot more normal. If I come from the world of software security, a chat GPT is good to have, nothing against it. But I would love a model which is trained on specifically my type of data, my set of data. I am able to feed it my intellectual data and train it on my intellectual data. That way, the answers that the model will give would be a lot better suited to my domain, my way of working, and the intelligence that I need from it. So that is what is a personal opinion of Abhishek Chauhan, that in the future, instead of the large language models, we will have smaller models, but a lot more specific, a lot more contextual based on a domain, based on an industry, having the ability to answer much deeper in depth about that particular.
Wonderful. It matches with another expert opinion which says we need Indianized large language models working on Indian data, not on foreign data. Nowadays, we don't have many Indian LLMs. That is unfortunate. No. Coming back to the key on the security aspect, how do you build trust in security systems? Do you use explainable AI, or what do you use? You are the expert. You tell us. How do you build trust in security systems?
So, see, when we talk about a security system, we have to understand that security is not one you doing one particular thing and hoping your software is secure. Security are multiple checkpoints, multiple guardrails, all coming together to create a software which is a lot more secure. When we talk about security systems, we need to understand a security system is only as good as the data it has, its ability to interpret that data, its ability to do active monitoring. There is a lot of IP that exist within these systems. A lot of patents that have been created on specialized algorithms, specialized data science models which are able to perform certain operations which are used inside these security systems, which basically help us understand secure, like what you and me on see on a UI is the end user product, but internally there is a whole massive ecosystem that exists which is driving the end results which we see on the UI. That ecosystem is comprised of a lot of data that exist, raw data, then data science models that exist, algorithms that work along with these data science model to interpret that data, and then our ability to decompose softwares and understand those softwares, understand how open source ecosystem works, how the binaries work over there, and being able to understand that is not something which is a one day job. Sonatype has been doing this for the past 18, 19 years now, and that has helped us accumulate a lot of good historical context. Our ability to our ability to bring historical context along with predictive analysis to the real-time scanning mechanism is the baseline for why our customers trust us.
Questions. I have more questions. I will keep on with my questions, but the floor is open for the those who are online viewing this to ask Mr. Chauhan questions, because you will not get him every day. My next question is, what are the best practices for integrating automated security testing tools?
So all of us know that there is a sphere of software engineering called quality engineering, quality analysis, testing. Earlier, what used to happen is a lot of time used to go in testing because humans used to first understand the code being written, the functionalities that exist on the UI. Then they used to come up with test scenario, test cases. There used to be test data creation for particular environments, particular products over there based on the real time simulation of data. There used to be test data creation, and then all of it used to come together into either a human running a manual test, or someone writing the automation scripts to automate this going forward. It was a very lengthy process, a very time consuming process. And in all fairness, there was only a piece of it which was around the understanding of the functionality, which required specialization. It required specialization because you had to understand what what is the customer specific interactions, what are the customer use cases, how that particular functionality is going to be utilized by a customer. So there was a lot of domain specialized knowledge that was required for evaluating that. But apart from that, the test case writing, test data creation, writing the automation code in and anything, Casper, Selenium, TestNG, Playwright, doesn't matter. Any framework was still just work. You needed humans to do that because that was the way to do it. But now all of those things can be automated. All of those things can be done by uh, AI skill that can be created, a skill that will be able to write test cases based on the scenario that has been defined to it. It will be able to understand the scenario based on our understanding, and then it will be able to do the test case writing. It will be able to do the creation of the test data and the writing of the code in Selenium, Playwright, all of those framework for us. So one of the things is a lot of developers used to hate doing extensive unit testing. They felt that I have written this code, it works. But unfortunately, that was never the truth. Uh, Developers always had a blind eye to the flaws in their development, and that is where the test engineering played a very important role. Now, one of the key advantages is we can train the AI on different personas. There would be a persona based AI for the developer, which will write unit test case scenarios. But then again, there would be a persona based AI developed, which would be trained and skilled a lot more into the context of the functionalities of the application, the domain that exists, which will write test cases not from a code perspective, but much more from a end user perspective, from a client usage perspective. These two personas and the AI for them will come together into helping us create a automation which will be a lot more secure at the end of the day.
Please. Very well explained, sir. I have only a couple of questions more, and one is, how do you ensure that automated patches or fixes do not introduce regressions?
So there is no easy answer to that. The only way of doing it to make sure that they don't include regression is always make sure that whatever is being shipped out to the customer has been thoroughly tested. And it has to be tested using the various mechanisms that we have talked about today. Everything from a persona based AI skill doing unit testing to secure by design concept, shift left security over there, security scans, code quality checks. All of these things come together into develop a product which has to be fully regression tested before it can be shipped to the clients. And that is the only way the patches being deployed at the client sites are going to be secure.
Now, due to the paucity of time, the last question of the day: who is ultimately accountable for security? The developer or a security expert, or is it a joint responsibility?
I would say everyone that is part of the process, not just the developer, not just the security engineer, everyone. Everyone from the ideation to the delivery is responsible for security. Security is a joint responsibility principle. The product, the product team that thinks of the idea, from the business analyst who basically divides the initiative into epics and Jira stories, to the engineer developer who is writing the code, to the test engineer who tests it, to the build and release cycle that is responsible for building it, to the end to the end person who delivers the software. Everyone is equally responsible in this chain for security. If we leave security to one persona, we are opening up ourselves to a world of pain.
Thank you, sir. And like all good things come to an end, we have to end this show now. Thank you very much. It was very educative, and I am personally reading about secure application software. It will add to my knowledge. Thank you, sir, and I look forward to seeing you in Mumbai.
Same here, Dr. Rashri. It was a pleasure to join you today for this. It was a really well managed session and looking forward to meeting you in person soon.
Thank you, sir. Thank you.
Thank you all.